Hello everybody, welcome into another lesson. So today we are going to talk about slopes and rates of change. So a lot of this probably looks familiar to all of you, and it should by now since we're in Algebra 2, but here is a review of the slope of a line. So let's say you have one ordered pair in the coordinate plane and another ordered pair. The slope is the rise over the run, which is the change in y coordinates over the change in x, which is your second y coordinate minus your first y coordinate, all that divided by your second x coordinate minus your first x coordinate. So this should look pretty familiar to everybody by now. And let's talk about if the slope is greater than 0. So here's an example of a line with the slope greater than 0. As you can see, it rises from the left to the right. So this is what we're talking about, the end behavior of a line. It rises from the left to the right. Now, as we get into quadratic functions, absolute value functions, cubic functions, and other types, the left and right-handed end behavior will change. But for a line, it's constant. For a positive slope, it rises from the left to the right. And then if you have a negative slope, so here's an example of a line with a negative slope, it falls from the left to the right, so it keeps falling. Now if the slope itself is 0, you have a horizontal line, like you see here. Now the equation of a horizontal line is going to be y equals some constant. So if you remember the horizontal line, 0 slope, y equals. That's the Hoy component when you have the slope equals 0. You get a straight horizontal line. Then if your slope is undefined, you get a straight up and down vertical line. And that's the equation for that will be x equals some constant, and that comes in from the Vuck saying. Vertical line, undefined slope, x equals. So those are the end behaviors of the different types of slopes of lines. So we're going to just do a few examples where we find the slope of a line, then we'll do some other problems. Alright. So let's see here. Let's say I have the points 3, 2, as well as negative 4, 3. Alright, so I have the points 3, 2, and negative 4, 3. I'd like to find the slope of that line. So to find the slope, I will take my second y coordinate of 3 minus my first y coordinate of 2. I'll divide all that by my second x coordinate of negative 4 minus my first x coordinate of 3. Well, 3 minus 2 is 1. Negative 4 minus 3 is negative 7. Which would turn into a slope of 1/7. So the slope of this line would be negative 1/7 rather. So I have a negative slope. My line is going to fall from the left to the right. It's going to just be a constant falling function since it's a negative slope. Not going to do a lot of examples of this. I mean, everyone should know how to find a slope by now. Alright, so what about the points 1, negative 4? And then we have the points 2, then we have the point 2, 6. We want to find the slope of the line from 1, negative 4 to 2, 6. Well, again, we'll just define our slope, take your second y coordinate of 6 minus your first y coordinate of negative 4 all over your second x coordinate of 2 minus your first x coordinate of 1, Well, 6 minus negative 4 is 6 plus 4. That would be 10. Over 2 minus 1, well, that's 1. So the slope of this line would be positive 10. So you end up getting a slope of positive 10, which means the line would rise from the left to the right since you have a positive slope. All right. Now, let's see here. I have the point negative 7, 3 as well as negative 2, 3. So I need to find the slope between negative 7, 3 and negative 2, 3. Well, again, start out like you did before. Take your second y coordinate of 3 minus your first y coordinate of 3. Divide all that by your second x coordinate of negative 2 minus your first x coordinate of negative 7. Well, 3 minus 3 is 0. Over negative 2 minus negative 7 turns into negative 2 plus 7, which would be 5. Well, 0 over 5, that gives you a slope of 0. So the slope of this line is 0, which means I'm going to get a even horizontal line. It'll be a completely horizontal line. Now, you're probably wondering, how would you find the equation of this line? Well, since it's a 0 slope, which means you're going to get the equation y equals, you just take the y coordinate, since the y coordinate's the same for both of these points, and set it equal to your y coordinate. So the equation of the line would be at y equals 3. That's exactly what you would get, y equals 3. Now let's try to find a vertical line one. I'd like to do that next. Good one. Okay. So we have the point negative 9, 8 as well as the point negative 9, 2. So we need to find the slope of the line between negative 9, 8 and negative 9, 2. Well, of course, take your second y coordinate of 2 minus your first y coordinate of 8. Divide all that by your second y coordinate of negative 9 minus your first y coordinate of negative 9. Well, 2 minus 8, that's negative 6. Negative 9 minus negative 9 turns into negative 9 plus 9, which is 0. Well, what do you know? Division by 0 is undefined, so the slope of this line is undefined. So what does an undefined slope mean? That means you get a straight up and down vertical line. So for that, the equation would be x equals then. And to find the equation for x, since you have the exact same x coordinate for both points, you just put that value in, you would get that x equals negative 9. That would be the equation of the line, would be x equals negative 9. Alright, so that's basic finding the slope. Let's talk about a few other applications of it. Alright, I think we get the idea there. Alright, now we will talk about parallel perpendicular lines. So, let's say you want to determine if two lines are parallel to each other. You can use their slopes to do that. If the slope of the first line is exactly equal to the slope of the second line, then the two lines are parallel. I'm sure this is coming back to a lot of people too. And then of course you have perpendicular lines. Which means they intersect to form a 90-degree angle, a right angle. So now, a perpendicular line is when one slope, the slope of one line, is equal to the negative reciprocal of the other line. So the slope of one line equals the negative reciprocal of the slope of the second line. Another way to test this is you should be able to take the slope of the first line times the slope of the second line, and it should always come out to -1. So in order for a line to be perpendicular, both slopes multiplied by each other have to have a result of exactly -1. Or it's probably easier if you know that the slope of one line equals the negative reciprocal of the slope of the second line. That's how you would determine perpendicular. And then if it doesn't fit either of these cases, then it's neither. They just intersect at some point. So we'll do a few exercises here to determine if lines are parallel, perpendicular, or neither. Alright, so let's see. Line 1 has the points -1, 9, as well as -6, -6. Line 2 has the points -7, -23, as well as the point 0, -2. Alright, so we're going to use the slopes of each of these two lines to determine if they are in fact perpendicular to each other, or parallel to each other, or neither. So let's find the slope of line 1. I'll call it m sub 1, which would denote the first line. So for the first line slope, you'll take your y-coordinate of -6 minus your y-coordinate of 9, divide that by your x-coordinate of -6 minus your x-coordinate of -1. Well, -6 minus 9 is what? That's going to be -15 over -6 minus -1 turns into -6 plus 1, which would give you -5. Well, this would give you a slope of +3. So the slope of line 1 is +3. Now, let's go ahead and look at the slope of line 2. I'll denote that as m sub 2. So take your second y-coordinate of -2 minus your first y-coordinate of -23, divide that by your second x-coordinate of 0 minus your first x-coordinate of -7. Okay, well, -2 minus -23 is -2 plus 23. That would turn into +21. Over 0 minus -7 turns into 0 plus 7, so that'd be 21 over 7. Well, what do you know? The slope of line 2 is also 3. Notice these two slopes are equal to each other, right? We can say that slope 1 equals slope 2. Therefore, line 1 is parallel to line 2. Notice I'm using that geometry notation again. But since the slopes are equal, we can say that line 1 is parallel to line 2. Let's do a few more of these. Alright, the points are going to change here. Alright, so let's see. Line 1 goes through the point, let's see, so far we have 4, -3, as well as -8, 1. Then line 2 goes through the point 5, 11, as well as the point 8, 20. Alright, so line 1 passes through the points 4, -3, and then -8, 1. Line 2 passes through the points 5, 11, and 8, 20. We need to determine, are these two lines parallel to each other, perpendicular to each other, or neither? And if they're neither, they just generally intersect. So let's find the slope of line 1 to start with. So m sub 1, the slope of line 1, take your second y coordinate of 1 minus your first y coordinate of -3, divide that by your second x coordinate of -8 minus your first x coordinate of 4. Okay, so 1 minus -3 turns into 1 plus 3. Well, that's 4. Divide that by -8 minus 4. Well, that's -12. 4 divided by -12, well, that gives you a slope of -1/3. Very good. So you get a slope of -1/3 for line 1. Now let's find the slope of line 2. So m sub 2, that's going to be, of course, take your second y coordinate of 20 minus your first y coordinate of 11, divide all that by your second x coordinate of 8 minus your first x coordinate of 5. So 20 minus 11, that's 9. 8 minus 5 is 3. Well, what do you know? Slope of line 2 is positive 3. The slope of line 1 is -1/3. Well, what do we know? Isn't it obvious that -1/3 and positive 3 are negative reciprocals of each other? So we can say that the slope of line 1 is equal to the negative reciprocal of the slope of line 2. And if you multiplied -1/3 and 3, you would get -1. Therefore, line 1 is perpendicular to line 2 since their slopes are negative reciprocals of each other. I got two more of these, then we're going to talk about rate of change. So let's talk about, let's do two more of these types of problems, then we'll talk about rate of change and what that is. So this time, line 1 goes through the point 0, 3, as well as 0, -7. Line 2 goes through -6, -4, and the point 12, -4. Alright, so we need to determine if line 1 is parallel to line 2, perpendicular to line 2, or neither. So let's go ahead and find the slope of line 1 here. So that'll be m sub 1. So take your y coordinate of -7 minus your y coordinate of 3. Divide that by your x coordinate of 0 minus your other x coordinate of 0. Well, you end up with -10 over 0, which means your slope is undefined for line 1. Now, what about the slope of line 2? So m sub 2. So take your y2 of -4 minus your y1 of -4, divide that by your x2 of 12 minus your x1 of -6. Alright, so -4 minus -4 turns into -4 plus 4, so that'd be 0. 12 minus -6 turns into 12 plus 6, that'd be 18. 0 over 18 is 0. So the slope of line 2 is 0. Well, here's the thing. What is the graph of an undefined slope? It's a straight up vertical line. What's the graph of a zero slope? It's a straight horizontal line. If they intersect, we know they're going to be perpendicular. And an undefined slope, right, would definitely equal the negative reciprocal of a zero slope. Since an undefined slope has a zero in the denominator, you can clearly see that the slope of line 1 is the negative reciprocal of line 2. So therefore, line 1 would be perpendicular to line 2. So if you have a zero slope and an undefined slope, they are perpendicular. And let's do the last one of these, then we'll do a few rates of change, then we'll be done. Alright, so line 1 goes through the point starting with 110 as well as 515. Line 2 goes through the point 3 halves, 3 halves, as well as through the point 4, 2. Alright, so again, we need to determine, are these two lines parallel to each other, perpendicular to each other, or neither? Well, let's find the slope of line 1. So the slope of line 1, of course, you take your y2 of 15 minus your y1 of 10, divide all that by your x2 of 5, minus your x1 of 1. 15 minus 10 is 5. 5 minus 1 is 4. So the slope of line 1 is 5/4. Okay. What about the slope of line 2? So slope of line 2, of course, you'll take your y2 of 2 minus your y1 of 3 halves, divide that by your x2 of 4 minus your x1 of 3 halves. Okay, so what is 2 minus 3 halves? That'd be 1/2. So you'd have 1/2 over 4 minus 3 halves. That'd be 5 halves. So you have 1/2 over 5 halves. So when you have a complex fraction, you invert and multiply. So it'd be 1/2 times 2/5, which 2's would cancel out. The slope of line 2 is 1/5. Okay, so they're definitely not the same slope, clearly not, so they're definitely not parallel. And they're not even negative reciprocals of each other, because if you took 5/4 times 1/5, you would get a result of positive 1/4. You need it to be -1 for them to be perpendicular. So they are neither parallel nor perpendicular to each other. That means they just generally intersect at some point, which we're not here to solve for that today. So there's a time coming where we'll solve for that stuff, but not in today's lesson. All right. Now we're going to talk about a rate of change. So let's talk about rate of change. This is a term you're going to hear a lot more of, and you may have heard of it already a little bit in previous courses. Rate of change is like slope, only it compares two quantities. For example, you have miles per hour. That's a rate of change. If you have feet per second, that's a rate of change. You're comparing the change in feet over the change in seconds. You're comparing the change in miles to hours. Or let's say I wanted to compare dollars to minutes. So I have so many dollars per minute. I'm either increasing so many dollars per minute, or I'm losing so many dollars per minute. Those are examples of rates of change, but it's the same idea as a slope. But as we get into calculus, we'll be dealing with what's called derivatives to figure out rates of change. It's just fancier slope. So here's what we're going to be given. So let's see. Had $3 in 4 hours. Then I had $27 in 8 hours. So this is going to be calculating a rate of change. We want to figure out the change in dollars per hour. That's what we want to figure out. So it's a lot like slope, right? To find your rate of change, to find the rate, you're going to figure this out in dollars per hour. So you'll take your second dollar of $27, that's like your Y2, minus your first dollar amount of $3, that'd be like your Y1, divide that by your second hour amount of 8 hours, minus your first hour amount of 4 hours. Well, what is 27 minus 3? That would be $24. So in 4 hours, I've increased $24. But what would this rate be in just 1 hour, right? We want to figure out what would this rate be in just 1 hour. To get a rate of change, what's your time or your other unit, you're trying to always make your denominator equal to 1. So you're going to divide both your numerator and denominator by that 4. So if I divide 24 by 4, I would end up with 6. And then 4 by 4 is 1. So I'm increasing at a rate of $6 per hour. That would be my rate of change at $6 per hour. Alright. What's the next one? There's only 2 of these. Alright, so I'm going to do another rate of change comparison. So I was already at 5 meters in 0 seconds, and then at 3 seconds I ended up at 17 meters. What is my rate of change, or in other words my speed, in meters per second? So let's go ahead. We want to figure out meters per second. That means my y variable is meters. So I'm going to take my second distance of 17 meters minus my first distance of 5 meters. Divide that by my first time of 3 seconds minus my first time of 0 seconds to figure out my rate of change. Well, what's 17 minus 5? That's 12 meters. So then 3 seconds minus 0 seconds, that's 3 seconds. So I've gone 12 meters in 3 seconds, but what is my rate of change per 1 second? If I want to get it per 1 second, I divide both numerator and denominator by 3. 12 divided by 3 is 4, and 3 divided by 3 is 1. So my rate of change is going to be 4 meters per second. I increase 4 meters per second. And I got one more of these rates of change. Alright, at 10 inches in 2 years, at 16 inches in 4 years. Alright, so this is a good type of problem. I start out at 10 inches in 2 years, and then in 4 years I end up at 16 inches. This can be used to indicate stuff like continental drift between continents, or even growth of a child, if a child's growing. So let's find how many inches per year. What is the rate of change? So take your second set of inches, which would be 16 inches, minus your first set of inches, which would be 10 inches. Divide all that by 4 years minus 2 years. Well, that would simplify into 16 minus 10, that is 6 inches. In 4 years minus 2 years, that's 2 years. So in 2 years, I've increased 6 inches. Well, I want to find the rate per year. So I divide numerator and denominator by 2, which would turn into 3 inches per year. So I'm either growing or the continents are drifting or whatever at a rate of 3 inches per year. That would be the rate of change, 3 inches per year. So that's it for slopes and rate of change. Next lesson, we're going to do quick graphs of linear equations, which will involve the slope-intercept form of a line and the general or standard form of a line. So I hope everyone has a great day. Take care.